So we'll say this is 7.3 part 2. Pyramids. Nets and triangles, I guess is what we're talking about. All these different parts that show up when we do problem with pyramids. So the example that I'm going to use is a square pyramid. So let me draw a square pyramid, and we did a few of these on our homework last night, but I want to talk a little bit more about the nets of pyramids. So here's going to be my square pyramid.
Is that going away from us or at us?
It's supposed to be going up. And I guess depending on how you see it, you could be looking at the bottom of the base or looking inside the pyramid at the top of the base.
Yeah.
It kind of switches around sometimes. And then let's draw in our slant height here. Here's our slant height that goes from the vertex down the side, and it makes a 90-degree angle with the base. So this is our slant height. And we're going to say that this is we said it's a square pyramid. So now I'm going to draw a net for this square pyramid. So our base is going to be a square. And then from each side of that square, I just end up with this, with a triangle. And I know my net's not going to be perfect, but we'll get the idea here. So this is true for a net of any pyramid. You just draw the shape of the base, and then the triangle comes off each side. So there's going to be a net, a rough idea of a net for my pyramid. You guys, let's put the electronics away, please. So if I take this slant height and I draw it in on my net, the slant height is going to go down the middle of each of these triangles. So that's going to be where the slant height would end up when I make my net. So each of those is the slant height. And let's say that the base of our square pyramid is 4 units. So we'll say this is 4 units. So each of these sides is 4 units. Well, if we look at this slant height on the net, on our net of our pyramid, what part of the triangle would we call the slant heights? If we're just looking at these triangles, what would we call those slant heights? That would be the height of our triangle. And to find the area of the triangle, we would take the base of the triangle, which is 4 units, times the height, which is the slant height, and divide that by 2. And I have 4 of those. Well, if I take 4 bases, 4 of these sides, and add them all together, what do I get? The perimeter of the base. So if I add up the areas of all of those triangles, which I get by taking one side of the base times the slant height and divide by 2, if I add all those up, I get the perimeter of the base times the slant height divided by 2. So the slant height, we said L equals the height of the triangles. The area of triangles equals L times 4 divided by 2. And we're multiplying that by 4 because we have 4 of those. So we have 4 triangles. We're multiplying it by 4. So that equals the slant height times the perimeter divided by 2, because 4 times 4 sides gives me the perimeter of the base. So the area that I get this L times P divided by 2 is just the area of all of these triangles added together. And then B is the area of the base. So the surface area is just the area that I get from adding all the areas of the triangles together plus the area of the base. So our formula comes from dividing our pyramid, cutting it open into a net, and then just adding up the areas of all the shapes that are inside there. But just like with a prism, I cut it open, lay it flat, add up the area of all the pieces, and that's where my formula for the surface area comes from. Exact same idea as we talked about before. Any questions on that? So just like I said with prisms, if you can't remember what the formula is, or you can't remember how it works or what the parts are, draw a net for your pyramid and just find the area of all the pieces and add them together. And that'll give you your surface area. So a net, finding the area of all the pieces in your net will give you the same surface area as the formula, because the formula comes from the net. Okay? All right, the next thing I want to show you is a demonstration of where the volume formula comes from. So let me get that pulled up here. You really can't write it down. It's kind of an animation, but I just want you to see it so that you have an idea, so you know where our formula comes from. Because we know our formula, our volume is the area of the base times the height divided by 3. And we decided yesterday that that's 1/3 the volume of a prism with the same base and the same height. So what we're going to do is, here's my prism. We'll say this is a rectangular prism. And what we've done here is we're dividing this prism into 3 pyramids. So the first pyramid is blue. The area of the base of the pyramid is the same as the area of the base of the prism. It's just this rectangle. The height of the pyramid is the same as the height of the prism. It's just one side here. So the area of the base of this pyramid and the height of the pyramid are the same as the area of the base and the height of the prism. Well, here's a green pyramid that's made the same way. Same area of the base, same height. And here's an orange pyramid, same area of the base, same height. Now I'm going to open these up. I'm going to unfold this. If I unfold this, I end up with 3 identical prisms. The area of the base, pyramids. The area of the base is the same as the area of the base of the prism. The height is the same as the height of the prism. And if I fold these 3 up, put them together, they make one prism. So the volume of these 3 added together has to be the same as the volume of the prism. Each one has the same area of the base and the same height. So the volume of one of them has to be 1/3 the volume of the prism. So I can always divide a prism into 3 pyramids that all have the same volume, that fit perfectly together to make my prism. So that's where our formula comes from, is from dividing a prism into 3 pyramids that are exactly the same size. Each one has the same volume, so the volume of one of them has to be 1/3 the volume of the entire prism. So that's where our volume formula comes from, dividing a prism into 3 pyramids. Questions on that one? And this was more just so you kind of have an idea of where the formula comes from. All right, I have one other demonstration or one other animation that I want to show you. This one shows the right triangles that I was talking about inside a pyramid. And again, I'll have these up here on the desk that you can look at. But this is a square pyramid. Here's the first right triangle that I talked about. This is the height, the slant height down the side here, and this is the apothem of the square, or halfway across the square. So I get a right triangle there inside my pyramid, and that shows up a lot in solving problems with pyramids. Another right triangle that shows up in pyramids is right here on the face of the pyramid. So this is just on the side of the pyramid. This is the slant height. This is half the side length, and this is one edge of the side. So that's another right triangle that shows up in problems that have to do with pyramids. That one sometimes shows up also. The height. This is the radius of the square from the center to the corner, and this is along one edge. So that's another right triangle that you might have to use to solve problems with pyramids. These we don't use so much. That one's one we've talked about before. That's just dividing the square in half. So that divides the square into a 45, 45, 90. But that's also a right triangle. And this one we've talked about before. Again, a 45, 45, 90 triangle there on the base. If we have a triangle, we end up with a 30, 60, 90 triangle. If we have a hexagon, we end up with a 30, 60, 90 triangle. So those are all triangles that end up inside pyramids that you have to remember and that show up a lot when we're solving problems with pyramids. All of those different right triangles, you might need to use the Pythagorean theorem or special right triangles to solve for parts of the lengths of parts of the pyramid that you need in your problem. So you need to be aware that those are all there. They show up a lot in problems with pyramids. Any questions? All right.